This is the solution for the last problem on the balancing skeleton equations worksheet. This one reads, ammonium hydroxide reacts with iron 2 phosphite to produce ammonium phosphite and iron 2 hydroxide. So I'm going to look through for my key terms for where my pluses and my arrows go. And in this, I see 3 places. Along the top line, I have reacts with, which is going to be a plus sign. In the middle line, I have to produce, which is an arrow. And then I also have the word and, which means that I'm going to have another plus sign. So taking all of this from the skeleton equation and putting it together to make the chemical equation, I'm going to end up with this. Ammonium hydroxide is NH4OH plus iron 2 phosphite, which is Fe3PO32, to produce ammonium phosphite, which is NH43PO3, and the plus sign, iron 2 hydroxide, which is FeOH2. Now the next thing I'll need to do is balance my equation, and the first thing that I recommend starting with is looking for any metals, and I see that I have the metal iron, and I see on the left side of my reaction arrow I have 3 irons and I only have 1 on the right side. So to balance the iron, I'm going to multiply the right side iron by 3, which means I'll have 3 on each side of my arrow now. And everything else I see in my reaction is a polyatomic ion. I have the ion ammonium, I have the ion hydroxide, and the ion phosphite. I'm going to start with ammonium, which is NH4. On the left, I see that it is not in parentheses, which means I have 1. And then on the right, I see that it is in the parentheses, and I have 3 of them. So I'm going to multiply the left side by 3 in order to balance the ammonium. I'm then going to move on to my next ion, which is the hydroxide that I see. That's the next one in the list anyway, so OH. Now that I've put that coefficient of 3 on the left side, I now have 3 hydroxides on the left, and on the right side, I also multiplied the term that has the hydroxide in it by 3. However, that hydroxide was also multiplied by 2, which means I have a total of 6 hydroxides on the right. Well, I have coefficients in front of both my terms, which could potentially be a problem. So I'm going to hold off on looking at the hydroxide, and I'm going to come back to it. So just keep it in your head that it's still there and you need to come back to it. And move on to the one last thing remaining, which is the phosphite. Well, the PO3 on the left side is in parentheses and there's 2 of them. On the right side it is not, which means there's only 1. So I need to balance the phosphite by multiplying that term on the right by 2. And in doing so, I see that I now have unbalanced my ammoniums. I now see that on the right side of my arrow, by multiplying that term by 2, I have 6 ammoniums, and on the left I only have 3 now. But I had that problem where hydroxide, I had 3 on the left and 6 on the right, and now I have the same problem with ammonium. I have 3 on the left and 6 on the right. So to fix that problem, I actually need to change my coefficient on the left to be 6, because I need 6 ammoniums and 6 hydroxides, because that's how many I have on the right side of the arrow. So that's what I'm going to do. I'm going to change my coefficient of 3 to a 6, and now I'm going to go back and double check that I have the right amounts of everything. So on the left, I have 6 ammoniums, and I have 6 ammoniums on the right. On the left, I have 6 hydroxides, and I have 6 hydroxides on the right. On the left, I have 3 irons, and I have 3 irons on the right. And then on the left, I have 2 phosphites, and I have 2 phosphites on the right as well. So I now have a balanced equation.